Hello everyone, welcome back to Class 6 series on my channel Mathify with Minakshi. Today we are starting a very interesting chapter, chapter 5 prime time. But before we start, just imagine you have 12 students in your class and you want to divide them into equal groups. Can you make groups of 2? Yes. Can you make groups of 3? Yes. Can you make groups of 4? Yes. But can you make groups of 5? If I will make a group of 5, then 5 students in one group, 5 students in next group, but 2 students will be left. That means we can't make group of 5. So what's actually happening here? Why do some numbers divide perfectly and some don't? The numbers that divide 12 exactly are called its factors. So let's see this topic now, factors and its property. As I just discussed, a number that divides another number exactly. When we say exactly, that means without leaving any remainder. So then we can say that those numbers are factors of number. Example, when we have to find the factors of 12. So you should know which numbers divides 12. 1 divide 12, then 2, then 3, then 4, then 6, and last 12. There is one more way to find factors. Just see when we'll get 12. 1 into 12, 2 into 6, 3 into 4. That's it. So these 1, 2, 3, and 12, 6, 4 all are factors of 12. Now you should know the properties of factors. As you know that 1 is a factor of every number, because if someone will say find the factors of 15, that is 1 into 15. If someone will say find the factors of 17, that is 1 into 17. So 1 always divides a number. So 1 is a factor of every number, but 0 is not a factor of any non-zero number. You know that 0 is not a factor of any non-zero number because 0 doesn't divide any number. So this is an important thing. Now let's move to second property. Every number is a factor of itself. If 1 is a factor of a number, then obviously number is also a factor of number. As you can see here, if someone will say find the factors of 18, you will write 1 into 18. That means 18 is also a factor of 18. So number and 1 are always the factor of number. Third, factors of a given number are always finite. As you can see here, for 12, it's 6 factors. Why it's finite? Because factors are always from 1 to the number itself. So it's always finite. You know the limit. And last, factors of a number are less than or equal to the given number. As you can see with the help of example, here the factors of 12 is either 12 or less than 12. All are less than 12. So that means factors are less than or equal to the given number. Now we'll move to the next topic, multiples. For that I will give you one real life example. Suppose one packet has 6 biscuits, and if you buy more packets, total biscuits will be it's 6, 12, 18, 24, 30, and so on. It depends how many packets you will buy. So similarly, we can say whenever we keep adding the same number again and again or multiplying the number by a natural number, we get multiples. So what are multiples? Multiples of a number are obtained by multiplying it by a natural number. And you should know what are natural numbers: 1, 2, 3, 4, and so on. So examples of multiples of 6: 6 into 1, 6. 6 into 2, 12. 6 into 3, 18. And 6 into 4, 24. And so on. So basically table of 6, you can say. Now we'll go to next topic, properties of multiples. The number of multiples of a given number is infinite. Why it's infinite? Because you are multiplying the number by natural numbers to get the multiples, and natural numbers are infinite. So that's why your multiples are also infinite, because you can multiply 6 with any number, by lakh, by crore, by billion, by trillion, any number, you will again get the multiple of 6. That's why it's infinite. So factors are finite, but multiples are infinite. Now, second point, every multiple of a number is greater than or equal to the number. In case of factor is less than or equal to, but in case of multiple, it's greater than or equal to. Why? You can see here, multiples of 6 will start from 6 and goes on. So least is the number itself and then goes on. Third point, every number is a multiple of itself. As you can see here, 6 multiple is 6. We always start with 6 because into 1 will give you the same number again. And fourth, every number is a multiple of each of its factors. Like I will write 4 and 2. So you can say that 2 is a factor of 4, and on the same way you can say 4 is a multiple of 2. So you can see here that here 4 is a multiple of its factor 2. Now let's move to next topic, and that is some basic definitions. So first you should know the difference between even numbers and odd numbers. Numbers that are multiples of 2 or that are divisible by 2 are known as even numbers. It's very simple, just see the table of 2, 2, 4, 6, 8, 10, 12, and so on. And for odd numbers that are not multiples of 2, if it will not come in a table of 2, you can say all the numbers are odd numbers. 1, 3, 5, 7, 9, and so on. Now let's move to next difference, prime number and composite number. What are prime number? A number that has only two factors. Only two. And those two factors are 1 and the number itself. Then the number is known as prime number. Example 2. How many factors we have for 2? It's only 1 and 2. For 3, factors are 1 and 3. For 5, factors are 1 and 5. So whenever we have only two factors, 1 and the number itself, then you will say that that number is a prime number. So I have written all the prime numbers between 1 to 100. Also, you know that prime numbers are not just till 97, it will go on, but I have written till 100 because you should know at least these prime numbers. Now let's move to composite number, a number that has more than two factors. So when a number have two factors, you will say that that's a prime number, and whenever the number have more than two factors, then it is known as composite number. Example 4. So you can say 1, 2, 4. It have three factors. For 6, it's 1, 2, 3, 6. 4 factors, again more than 2. So whenever we have more than 2 factor, it's a composite number. Now maybe you are thinking that when we have 2 factor, it's a prime number. When we have more than 2 factor, it's a composite number. What if we have one factor of a number? Then it's neither a prime nor a composite, because we have only one number, that is 1, which have only one factor, that's 1. So here we have only one factor, and that's why it's neither a prime nor a composite. One more thing I want to tell you, as you will realize that in the list of prime numbers, we have only one even number, and that's 2. So 2 is the only one and smallest even prime number. Other even numbers are not prime, they are composite. So now let's move to next definition, twin primes. What are twin primes? Pair of prime numbers whose difference is 2. So for twin prime, we need two things. As you know, one word is primes, so we need prime numbers. And second is twin, that means difference is 2. So we just need these two things. So you have to select two prime numbers whose difference is 2. So you can say 3, 5, 5, 7, 11, 13, and so on, like 41, 43. We have so many options. So you can select anyone, 59, 61, and so on. Now co-primes. What are co-primes? Now don't focus that we have primes here. So that means number should be prime. In this case, if both the numbers are not prime, still they can be co-prime. So you should know the definition of co-prime. The definition of co-prime is if the numbers HCF is 1. That means that they have only one common factor, 1. They don't have any other common factor. So that's the definition of co-prime numbers. So if you will take two numbers, you feel that they have only one common factor and that is 1, then you can say that those two numbers are co-prime. But I want to tell you one thing here. Note that when you will take any two prime numbers, then no need to think anything, because when the numbers are two prime, they are always co-prime, because between two prime numbers we have always only one common factor, that is 1. And whenever you will take two consecutive numbers like 2 and 3, 3 and 4, 4 and 5, 5 and 6, regardless that they are prime or not, no need to think anything. If the numbers are continuous, or you can say consecutive, they are always co-prime. So two things I already told you, that when the numbers are always co-prime, when both are prime, when both are consecutive numbers. And the basic definition, when the HCF is 1, like 4 and 9. They are neither prime nor consecutive, but still they are co-prime because their HCF is 1, highest common factor, because the factors of 4 are 1, 2 and 4, and the factors of 9 are 1, 3 and 9. So common is only 1. That's why they are co-prime. So here you should know one point, if it will come in true or false, that co-prime numbers are always prime numbers. Not true. It might be possible that the numbers are not prime, but they are still co-prime. Okay. Now let's move to next, that is perfect numbers. Now what is perfect number? A number is called a perfect number if the sum of all its factors, excluding the number itself, is equal to the number. If you're excluding the number itself, then it's equal. If you're not excluding the number, then it's double the number. Like you can see here, what are the factors of 6? Factors of 6 are 1, 2, 3 and 6. If you will exclude this 6 and you will add these 1 plus 2 plus 3, you will get the number itself, that they are saying equal. And if you want to take all the factors like 1, 2, 3, 6, and when you will add this, you will get 12. That's double of this. So we have two definitions. If you're not excluding the number, then you will get sum as equal to the number. If you're not excluding the number, then you will get sum as double of the number. So we have one more number, that's 28. If you will see carefully, the factors of 28 are 1, 2, 4, 17, and when you will add, you will get 28. So again, this is also a perfect number. Here I want to tell you one more thing, although that's not in your book, but still I want to tell you as extra knowledge, that we have more perfect numbers. It's not like that we have only these two numbers as perfect numbers. So they are 628, then it's 496, 8128, and then it's too big like 33550 and so on. So we have so many perfect numbers, but no need to learn other ones. You have to just learn 6 and 28. Now let's move to first figure it out of this chapter, that's on page number 108 of your textbook. But before starting this figure it out, you should know one game that's on your book, Idli Vada game. So I will tell you what's the game about. All students will sit in a circle and start counting numbers one by one. But there is a twist. If a number is multiple of 3, a child will not say 3, they will say idli. And if the number is a multiple of 5, then they will say vada. So let's start. 1, 2, idli. 4, vada. 6, they will say, instead of 6, what they will say? They will say idli. Then 7, 8, instead of 9, yes, they will say idli, it's correct. Then 10, they will say vada. 11, 12, 12 is again idli. 13, 14, now 15. Just see one thing, 15 is a multiple of 3 as well as multiple of 5. So child will say idli vada together. Then 16, 17, now 18. 18 is a multiple of 3, so idli. 19 and so on. So I think now you know the game. For multiple of 3, a child will say idli. For multiple of 5, vada. And if a number is multiple of both, then they will say idli vada. And if anyone makes a mistake, they are out of this game. The game continues until only one player is left. And through this fun game, we learn about multiples of numbers and common multiples. Like here, 15 was common multiple of 3 and 5. So if you know first common multiple of these numbers, now you know that multiple of 15 like 30, 45, 60 will say idli vada. Now let's start the figure it out. Question number 1. At what number is idli vada set for 10th time? Now you know that when we'll say idli vada 10 time, we know that we'll say idli vada first time on 15. So 10th time means that's a 10th multiple of 15. So you can write 10 into LCM, or you can say first common multiple of 3 and 5. What is this? First common multiple of 3 and 5. So answer is 10 into 15, that is 150. Now let's move to second question. If the game is played for the numbers 1 to 90, only till 90, then find out how many times would the children say idli, including the times idli vada. So what I will write? For this you will say that idli is said for a multiples of 3. For all multiples of 3. That is 3, 6, 9, 12, 15, and so on till 90, because 90 is also a multiple of 3. So they are saying how many times. This implies idli is said for how many times? How will find that? You will simply divide 90 by 3. That means 30 times. If you will cut this, you will get 30 times. Okay. Now next they are saying how many times you will say vada. Again the numbers are till 90. So you will write vada is said for all multiples of 5. I'm not writing till 90 because that's already mentioned in question. That is 5, 10, 15, 20, and so on till 90. 90 is also a multiple of 5. So vada is said for how many times? You will divide 90 by 5, and that is 18. That means 18 times. And they are saying how many times you will say idli vada. Now you know that idli vada is set for all multiples of 15. That is 15, 30, 45, 60, and so on till 90. You can write, although we have only now one number left, that's 75. So how many numbers we have here? 6. You can say idli vada is set for 16, set for 6 times. And you can find this like this to 90 divided by 50. 6 times. Now they're saying, what if the game was played till 900? Instead of 90, the game is played till 900. So now you know that how we can do that. Just write idli is set for, now I'm writing directly, how many times? Just divide 900 by 3, because we have to see multiples of 3. That means 300 times. For vada, we will divide by 5. Vada is set for dash times. That means 900 divided by 5. You can say 180. And similarly, idli vada is set for 900 divided by 15. That means 60 times. Easy. Now let's move to last question of this figure it out. If this figure is somehow related to the word idli vada game, imagine playing the game till 30. Draw the figure if the game is played till 60. Now if you have to play the game till 60, just draw these circles. One side you have to write multiples of 3. One side you will write multiples of 5, and in between you will write common multiples of 3 and 5. That means multiple of 15s. Common multiples of 3 and 5, that is, you can say multiples of 50, because you know LCM of 3 and 5 is 50. So let's start. If a number is a multiple of 3, you will write here. If a number is multiple of 5, you will write here. And in common, you will write multiple of 15. So let's start. 3, 6, 9, 12. 15 will write here. Then 18, 21, 24, 27, 30 will write here. 33, 36, 39, 42, 45 here. 48, 51, 54, 57, and 60 you will write here. Now see the table of 5. 5, 10, 15 we have written, 20, 25, 30 we have written, 35, 40, 45 we have written, 50, 55. We have to just write the numbers till 60. So that's it. This means that for these numbers, a student will say idli. For these numbers, student will say vada. And for these common ones, students will say idli vada. Now let's move to one extra question that's given on page number 108 of your book. Here we have two boys. First boy said, yesterday we played this game with two numbers. We ended up saying just idli or idli vada. That means nobody said vada. Second boy said, oh, what could be those numbers? Then first boy replied, one of the numbers was 4. So now question is, which of the following could be the other number? 2, 3, 5, 8 or 10. So for this you should know, for vada to never appear, every multiple of the larger number must also be a multiple of smaller number. Multiple of the smaller number. So if you are taking 4 as smaller number, then you can take other number as its multiple. So here from these option answer is 8. Although it can be anything 8, 12, 16. But from options we can say 8. And when you are taking this 4 as larger number, then you can take any number as its factor. That means 2. So here we have two possibilities when you will never say vada, you will just say idli or idli vada. That is when the numbers are 4 2 or 4 8. So that's it for today. Now we'll continue this chapter in next video. If you found this video helpful, don't forget to like, share and subscribe to my channel Mathify with Meenakshi. Thank you everyone.